Hi guys, in today's video we are going to do coordinate geometry questions of O-level math starting from 2020 till 2024. Mind you, some of these questions will also have parts that include vectors. So let's start. So the first question says Q is the point n and -4, R is the point -1 and 8, and S is the point 3 and 2. The length of QR is 13 units. Find the two possible values of n. In order to find the value of n, first of all, what you do is we write QR square, the formula for the length of the line QR. So QR square is equal to n minus -1 whole square plus -4 minus 8 whole square. When you solve this, this becomes QR square is equal to n plus 1 whole square plus -12 whole square. And QR over here is 13, so you do 13 square is equal to n plus 1 whole square plus -12 whole square. Now let's open all of this up. 13 square is 169. Then this n plus 1 whole square becomes n square plus 2n plus 1. And then this becomes plus 144. Now let's bring 169 to the right. This becomes 0 equals to n square plus 2n plus 1 plus 144 is 145. 145 minus 169 is -24. So we write -24. Since we're trying to find the values of n, you break the middle term, you break 24 into its factors. This becomes 0 equals to n square plus 6n minus 4n minus 24. 0 equals to n, taken out as the common factor, this becomes n plus 6. -4 taken out, this becomes n plus 6 again. So the two factors are going to be n plus 6 and n minus 4 equal to 0. So the values of n are going to be n equals to 4 and -6. So we write -6 and 4. The next part says RST is a straight line and RT is 2:5. Find the coordinates of T. So if you draw a straight line and you say that this is R, let's say, since I've done this question, I'll explain it better to you by drawing a line that's actually true. So R to S, and then T is over here. Now from R to S, this is 2 units, and this is going to be 3 units. So all of this is going to be 5 units. Technically, we are supposed to find the value of the coordinates of T, but this is a vectors question. First, you need to know what RS is. For that, we need the coordinates of R. The coordinates of R are going to be -1 and 8, -1 comma 8. The coordinates of S are going to be 3 and 2. So we write 3 comma 2 over here. Now let's find RS. In order to find RS, the vector is going to be RS is OS minus OR. So RS is going to be equal to OS is going to be 3 and 2 minus OR is going to be -1 and 8. Subtract them both. RS comes out to be 3 plus 1, 4. 2 minus 8, -6. So RS is going to be -6. Now, this ratio given to us, 2:5. This means that RS is only 2 parts and RT is 5 parts. That means this vector that we've just found, 4 and -6, if I multiply that by the ratio 5:2, that means I multiply this by 5/2, both the values. There's 5 times 4 gives me 20, 20 divided by 2 is 10, 5 times -6 gives me -30, -30 divided by 2 is -15. The reason why I multiplied by 5/2 is because if I multiplied by 2/5, then RS would become even smaller. And since RS becoming even smaller does not equal RT. Therefore, I flipped the ratio. I flipped 2/5 and I multiplied by 5/2 so that I can get the vector RT. This value over here, this vector is RT. Now, how do we use RT to find the coordinates of T? This is how we do it. The formula is going to be RT is equal to OT minus OR. And I'm sure you've learned this before. So in order to find OT, it becomes RT plus OR is equal to OT. So RT is 10 and 15, 10 and -15. And OR is going to be -1 and 8. It is given over here. When I add them, the values that I get, the answer is going to be 9 comma -7. And that is 9 and -7. Those are the coordinates of T. The next part says, find the equation of the perpendicular bisector of RS. First of all, in order to find the perpendicular bisector, you need to find the midpoint. How do you find the midpoint? The coordinates of R, what were those? They were -1 and 8. The coordinates of S above, let's see, let's check them. The coordinates of S were 3 and 2. The line that is going to be the perpendicular bisector will pass through the midpoint. So let's find the midpoint of them. So you do -1 plus 3 over 2. This will give you the x value, the x and the x added together divided by 2. Then you do 8 plus 2 divided by 2. This will give you the y value. That gives me -2 over 2. And this gives me 10 over 2. So the midpoint coordinates are going to be 1, 5. Now what happens over here is that at this point, there is going to be a perpendicular bisector drawn. But in order to find the equation of the perpendicular bisector, which is y equals to mx plus c, we need two things. We need m, that is the slope, the gradient, and we need the y-intercept, for which we are going to use these coordinates that we just found. But how do we find the slope? We need to find the slope of rs first. So the slope, the gradient of rs, it is going to be y2 minus y1. That means I do 2 minus 8 over 3 minus -1. 3 minus -1. This gives me -6 over 4. So this is going to give me -6 over 4 is going to be if I simplify this, -3 over 2. This is the slope of rs. But mind you that the slope of rs is going to be like the negative reciprocal of the slope of the perpendicular bisector. So this over here, this is the slope of rs. If I have to find a perpendicular bisector or any perpendicular line that is perpendicular to rs, I need to multiply this by -1 and then flip it. So the perpendicular bisector, let's call that gradient m2. The perpendicular bisector will have a gradient of 2 over 3. Why do I say this? Because any two perpendicular lines, when their gradients are multiplied, you get -1. So the gradient over here was -3 over 2 times m2 is equal to -1. m2 is the gradient of the perpendicular bisector, so I would do -1 times 2 over -3. That gives me 2 over 3. Now, since we have the gradient, we need to find the equation. In order to find the equation, you write y equals to 2 over 3 x plus c. We don't know what c is, therefore we are going to use these coordinates over here, 1 and 5. 5 is going to be placed inside of y, and 2 over 3 times 1 plus c. Let's find c. So 5 minus 2 over 3 equals to c. Let's use a calculator for this. 5 minus 2 over 3, 5 minus 2 over 3 is going to give me 13 over 3. So c is equal to 13 over 3, which you can write as 4 whole 1 over 3 as well, but that doesn't matter. So your equation finally of the perpendicular bisector becomes y equals to 2 over 3x plus 13 over 3. That's your answer. You write it over here. Y equals to 2 over 3x plus 13 over 3. Question 2 has given us a grid over here. It says point A and point B are shown on the centimeter square grid. ABC is a triangle. Here are 5 possible coordinates for point C. Okay, so the question is also telling us tick the 2 coordinates from the list that make ABC an isosceles triangle. The best way to do the question is, let's plot all the coordinates first. So if I plot all the coordinates, -2 and -2 and 4 is going to be over here. -2 and -1 is going to be here. -1 and -2 is there. 6 and 1 is going to be over there. And -4 and 6 is going to be over there. Now let's check them one by one. First thing, -2 and 4, this point over here. If I sketch a straight line from this point all the way to this point, let's find the distance. From this point, if this was C, this would be 3 units, but then A to C, in order to find this would be 2 units, this would be 3 units. That means this value, the length that you find for this, would be greater than 3 if you use the Pythagoras theorem. So this is not one of the coordinates. Cross it out. Now let's talk about the next point over here. The next point is -2 and -1. This point over here. If I stretch a straight line from this point, then it is possible that these two lines are equal to each other. So let's see. If I find the distance of this is going to be 4 units. If I call C C is the point over here. This is going to be, the vertical length is going to be 1, 2, 3, 4, 5 units, and the horizontal length is going to be 3 units. That means the Pythagoras theorem used over here would be 5 square plus 3 square, square root of that. Now let's do the same for A to B. This would be 5 units, because 1, 2, 3, 4, 5, 5 units, and then this would be 3 units, so this would be 3 again. So this is one of the points that makes an isosceles triangle, because using the Pythagoras theorem, both the lengths AB and BC come out to be the same. Let's check the next point over here. So this is one of the points. Now the next point is -1 and -2. If I stretch a straight line from A all the way to this point, let's see. Now we already know that from A to B, it is 5 and 3 units. From B to C over here, if I stretch a straight line like this is going to be 1, 2, 3, 4, 5, 6 units, 6 units and 2 units. I don't think that'll give us the same value, so this is not going to be one of our answers. Okay, let's move on. The next point is going to be at 6 and 1. That means I stretch a line like this and make it C. Now from B to C, I go 1, 2, 3, 4, 5 units, and I go 1 to 3 units down. So 5 and 3, and I go from B all the way to A like this. Again, they'll give me 5 units over here and 3 units over here. That means this makes another isosceles triangle like this. So C is one of our answers, like 6 and 1 is one of our answers. Let me check the last point as well. The last point is when I stretch this line from B all the way to this point and call it C. Now if I count the vertical distance from B to A, this is 3 units, and this distance again is 5 units. From this point all the way to this point is 2 units, and then this is 5 units. So this does not make the same length of BC and AB. This is not one of our answers. The only answers are the second and the fourth point over here. Okay. Now let's read the next question. The next part says, one second. The next part says, find the column vector AB. Column vector AB means you go from A all the way till B. So count the horizontal distance first. You go 1, 2, 3, 4, 5 units to the right. That means 5 units over here. Then you go 1, 2, 3 units up. So it is 5 and 3. You write 5 and 3 over here. One second. Now, the next point says A is the midpoint of the line DB. A is the midpoint of the line DB. Okay, that means the line would stretch something like this. It says find the length of DB. Now, first of all, in order to find the length of DB, if A is the midpoint of DB, let's say D is over here, then if from A to B the horizontal distance, was 5 units, then from D to B the horizontal distance would be 10 units. And then from A to B the vertical distance was 3 units, then from D to B the vertical distance would be 6 units. So technically we need to do DB is equal to the square root of 10 plus 6 square. Let's see what that is. 10 square is 100, 6 square is 36. Add them, you find the square root of 136, and the square root of 136 is going to be 11.7, and that is the length of DB. Okay, next part. It says the equation of line P is y equals to 4x minus 3. Line L is perpendicular to line P. Line L passes through the point 6 and 4. Find the coordinates of the point where L crosses the line, where the line L crosses the x-axis. The first thing that you need to do is, first of all, find the equation of line L. In order to find the equation of line L is perpendicular to line P. That means we use this equation to find the gradient of line L. The gradient of P, let's say, is 4, as it is given over here, and the gradient of L is the unknown. Now, according to the perpendicular rule theorem, if I multiply the gradient of line 1 and line 2, if they are perpendicular, they should give me -1. So this is 4, this is m2, this should be equal to -1. So m2 is equal to -1 over 4. The gradient of line L is going to be -1 over 4. Okay. Now, since the gradient of line L is -1 over 4, the equation of line L is going to be equal to y equals -1 over 4 x plus c. Now, we also have a point on the line. The line L passes through 6 and 4. To find the y-intercept, Let's plug in these coordinates. Let's plug in 4 over here, negative 1 over 4 times 6, and let's find out what c is. 4 minus, oh sorry, 4 equals to negative 6 over 4 plus c. C would be equal to 4 plus 6 over 4. If I use a calculator to find the value, 4 plus 6 over 4 is going to give me 11 over 2. So my equation of line L would be equal to y equals negative 1 over 4x plus 11 over 2. But that's not what the question is asking you. The question is asking you find the coordinates of the point where L crosses the x-axis. Now, if a line is crossing the x-axis that has a negative gradient, let's say it goes like this, right? This point over here is what we are looking for, the coordinates of this point. At this point, the coordinates would be x comma 0. The value of y is going to be 0. So in order to find the coordinates of x, all you need to do is plug y as 0 in place of y. So this is going to give me 0 equals negative 1 over 4x plus 11 over 2. Move the 11 over 2 to the other side. This becomes negative 11 over 2 equals negative 1 over 4x. Now, in order to find x, you do negative 11 over 4 times, or you can divide it, simply divide it by negative 1 over 4. Sorry, my bad. This is 11 over 2. When you divide it, negative 11 over 2 times negative 4 over 1. Sorry, my bad. Simplify it. This is 1, this is 2. That gives me 22. So the coordinates are going to be 22, comma 0. Of line L is 4y equals to x minus 5. Part 1 says find the gradient of line L. All you need to do is rearrange this equation. Take the 4 to the other side. This is going to become y equals to x over 4 minus 5 over 4. Now, the gradient is always supposed to be the coefficient of x, so that is going to be equal to, the gradient is going to be equal to 1 over 4. That's your answer. That's 1 over 4. The next part says find the coordinates of the point where line L crosses the y-axis. Now, as you can see on the y-axis, if line is crossing the y-axis, the x value is going to be 0, and we are supposed to find the y value. When the x value is 0, and if you plug that x value into this equation, that is going to leave us with y equals to negative 5 over 4. And the coordinates will be 0, comma, negative 5 over 4. The next part says A is the point 4 and 5 and B is the point negative 2 and 8. Find the length of line AB. In order to find the length of line AB, you do AB square is equal to 4 minus negative 2 whole square plus 5 minus 8 whole square. This becomes AB square is equal to 6 square plus negative 3 whole square. And that gives us AB square is equal to 36 plus 9. AB square is equal to 45. Then find the square root of 45. That is going to give us AB is equal to, let's find that out. Square root of 45 is going to be equal to 6.71. 6.71, that's the length of AB, 6.71. Then the question says find the equation of line AB. Give your answer in the form y equal to mx plus c. In order to find the equation of the line AB, first you need the slope of AB. In order to find the slope of AB, you do y2 minus y1 over x2 minus x1. y2 is going to be 8. As you can see over here, that's the y value. This is the y value as well. So this becomes 8 minus 5 over negative 2 minus 4. This is going to be 3 over negative 6. That's going to be negative 1 over 2. That is the slope. Now, in order to find the y-intercept, you have y equals to negative 1 over 2x plus c. You can plug in any one of these points. Let's plug in 4 and 5. If I plug in 4 and 5, y is going to be 5 and x is going to be 4. So the value of c comes out to be 5 equals to negative 2 plus c. C is going to be 7. So your equation of line AB is going to be y equals negative 1 over 2x plus 7. You write it over here, negative 1 over 2x plus 7. Question 4 says D is the point 4 and 6 and E is the point E and E. The length of DE is square root of 20. Form an equation in E and solve it to find the possible coordinates of E and show your working. Okay. Now, in order to find the length of DE, you do DE square is equal to 4 minus E whole square plus 6 minus E whole square. So D minus E whole square is under root 20. So you square this. This is equal to 16 minus 8e plus e square. And this is going to be equal to 36 minus 12e plus e square. Now you condense all the values. The square root of the square of the square root of 20 leaves me with the 20 over here. This is going to give me 16 plus 36. 16 plus 36 is going to be equal to 42. No, 52. 16 plus 36 is 52. So you write 52. And negative 8 minus 8e minus 12e gives me negative 20e, and this gives me 2e square. Now let's bring all the values to one side. This becomes 2e square minus 20e plus 52 minus 20 equals 0. This becomes 2e square minus 20e 20, and this gives me plus 32 is equal to 0. If I simplify this equation, this is going to give me e square minus 10e plus 16 equals 0. Now from 16, I'm supposed to find out the factors that make 10, negative 10. So I write e square minus 8e minus 2e plus 16 equal to 0. Then I take e as the common factor. This becomes e minus 8. I take negative 2 as the common factor. This becomes e minus 8 equal to 0. This becomes e minus 8 and e minus 2 equals to 0. So the two values of e are 2 and 8. Write them over here. Wait. It says form an equation in E and solve it to find the possible coordinates of point E. The possible coordinates of point E, if I use 2 and 2, that means I write 2 and 2 over here. If I use 8 and 8, I write 8 and 8 over here. The coordinates of point E are actually E and E. So both values are used together. So 2 and 2 and 8 and 8. The next question says F is the point negative F and 5F. The gradient of the perpendicular bisector of DF is 3 and 3 over 2. Find the value of F. First of all, in order to find the gradient of DF, you need the coordinates of D. The coordinates of D are given above. They are 4 and 6. That is 4 and 6. And the coordinates of F are given over here, this. In order to find the gradient, you do 6 minus 5F over 4 minus negative F. That simplifies to 6 minus 5F over 4 plus F. This gradient is, the question says the gradient of the perpendicular bisector of DF is this. So the gradient that I have over here and the gradient that I have over here, they are both, if I multiply them both together, I'm supposed to get negative 1. So if I multiply 3 over 2 by 6 minus 5F over 4 plus F, I'm supposed to get negative 1. Let's do it. 3 times 6 minus 5F gives me 18 minus 15F over 2 times 4 plus F gives me 8 plus 2F equals negative 1. If I cross multiply this with this becomes 18 minus 15F is equal to negative 1 times 8 plus 2F. This becomes 18 minus 15F equals to negative 8 minus 2F. Bring all the F values together. This becomes 18 plus 8 equals to negative 2F plus 15F. This becomes, wait 1 second, 18 plus 8 is going to give me 26. And negative 2F plus 15F is going to give me 13F. So F is going to be 26 divided by 13. F is going to be 2. The value of F is going to be 2. The next part says the equation of the perpendicular bisector of DF is 2y equals to 3x plus k. Find the value of k. The question is telling us that the equation of the perpendicular bisector of DF, the gradient is 3 over 2. And the equation of the perpendicular bisector is this over here. Now, since we have the value of 2, what we need to do is find the value of x and y over here so that we can plug it in to find the value of k. Now, how do we find the value of x and y? As you can see that we have already found the value of f. F, 1 second, is equal to negative f and 5f. And the value of f itself is 2. So I plugged in 2 over here. This becomes negative 2. And 2 times 5 is going to be 10. So the coordinates of f are negative 2 and 10. I write them over here. Coordinates of f are negative 2 comma 10. And the coordinates of d are going to be, the coordinates of d, they're 4 and 6. Okay, 4 comma 6. I need to find the midpoint of these 2 points. So I do negative 2 plus 4. divided by 2 to find the value of x, because I added this and this value of x. Then I do 10 plus 6 over 2, because I'm finding the value of y over here, that is 10 plus 6. When I do this, it becomes 2 over 2, comma 16 over 2, which gives me a point 1 and 8. 1 and 8 is a point that lies on this line, because the midpoint of DF is this, and the midpoint of the perpendicular bisector is also going to be negative 1 and, 1 and 8. So I plug these values of x and y in this equation. I plug in y in place of y, that is 2 times 8, and x in place of x, that is 3 times 1. That should give me k. 2 times 8 is going to give me 16. 3 times 1 is going to give me 3 plus k. So k is equal to 16 minus 3. K is it comes out to be 13. So the value of k is 13. Question says P is the point 3 and negative 3 and Q is the point 1 and 5. Calculate the length of PQ. In order to find the length of PQ, all you do is PQ is equal to the square root of 3 minus 1 whole square plus negative 3 minus 5 whole square. So PQ is going to be equal to 3 minus 1 is 2, 2 square is 4, plus negative 3 minus 5 is negative 8, and negative 8 whole square is 64. So PQ is equal to square root of 68. If I plug this into the calculator, one moment, square root of 68 is going to be equal to 8.25. So you write 8.25. The next part says find the equation of the perpendicular bisector of PQ. In order to find the perpendicular bisector of PQ, you need to find the slope of PQ first. The slope of PQ can be found by doing y2 minus y1 over x2 minus x1. So y2 is 5 minus negative 3 and x2 is 1 minus 3. That gives me 8 over negative 2. The slope is going to be negative 4. But this is the slope of PQ. Now, in order to find the slope of a perpendicular bisector, the slope of PQ multiplied by the slope of the perpendicular bisector should equal to negative 1. That means negative 4 times m2 is equal to negative 1. So m2 is equal to negative 1 over negative 4, that is 1 over 4. This 1 over 4 is the slope of the perpendicular bisector. Okay, so you have the slope, that means the equation should be y equals to 1 over 4 x plus c. But you have another problem over here, that is you don't have the value of c. In order to find the value of c, you are supposed to find the midpoint of PQ first, so that you can use that in place of x and y. So the coordinates of P and Q are 3 and negative 3 and 1 and 5, and the midpoint of PQ can be found by doing 3 plus 1 over 2, that gives us the x value, and you do negative 3 plus 5 over 2, that gives us the y value. So this becomes 4 over 2 and 2 over 2. Simplify this becomes 2 comma 1. This is the midpoint of PQ. This midpoint can be directly used into this equation over here. The equation is y equal to 1 over 4x plus c. So I use 2 and 1. I plug in 1 in place of y and I plug in 2 in place of x. I find out the value of c. That gives me 1 equals to half plus c. So c is equal to half or 0.5. So the equation is going to become y equals to 1 over 4x plus 1 over 2. Let's write that over here. Y equals to 1 over 4x plus 1 over 2. The question says A is the point negative 2 and 3 and B is the point 4 and 5. It says find the coordinates of the midpoint of AB. That is very simple. You do negative 2 plus 4 over 2 to find the x value, and you do 3 plus 5 over 2 to find the y value. That is going to give you 2 over 2 and 8 over 2, and the coordinates are going to be 1 comma 4. So you write them over here, 1 comma 4. The next part says show that the gradient of line AB is 3y equals to x plus 11. The line AB, first of all, we need to find the slope of AB, that is y2 minus y1 over x2 minus x1. The slope is going to be 5 minus 3 over 4 minus negative 2. That is going to give us 2 over 6 actually. This gives us 1 over 3. Now, since we have y equals to 1 over 3x plus c. We can use one of the points over here. I can use, let's say, if I use this point over here, that is going to be 3 equals to 1 over 3 times negative 2 plus c. If I multiply this, this becomes 3 equals to negative 2 over 3 plus c, and c would turn out to be 3 plus 2 over 3. That gives us, let's see what that gives us, 2 plus, sorry, 3 plus 2 over 3, that is going to give us 11 over 3. Now, since we have 11 over 3, let's make this equation out of this. So, right now, my equation is y equals to 1 over 3x plus 11 over 3. In order to convert this equation into this equation, I need to make sure that the 3 moves to the other side. How do I do that? First, I make y equals to 1x plus 11 over 3, as I take 3 as the common LCM. Then I multiply 3 on the other side with y, so the equation becomes 3y equals to x plus 11. That is how I show that this equation and this equation are equal. Then the question says, find the equation of the perpendicular bisector of the line AB. In order to find the perpendicular bisector of AB, first you need to find the slope of AB. And I think we already found the slope of AB, that is 1 over 3. Then we need to find the midpoint of AB. The midpoint of AB can be found by using these 2 points, negative 2 and 3 and 4 and 5. So you do negative 2 plus 4 divided by 2. In fact, we have already found the midpoint of AB, that is 1 comma 4. All you need to do is find the slope of the perpendicular bisector now. Now, since the slope of line AB is 1 over 3, that means let's call this M1, and let's call the slope of the perpendicular bisector M2. If I multiply M1 and M2, since these two lines are perpendicular, I should get negative 1. So I have negative 1 over 3 times M2 is equal to negative 3. M2 is going to be negative 3. The slope of the perpendicular bisector is negative 3. So you have y equals to negative 3x plus c. So I plug in these coordinates over here to find the value of c. So I plug in 4 in place of y and I plug in 1 in place of x. That gives me 4 plus 3, c is equal to 7. So my answer is going to be y equals negative 3x plus 7. That's my equation. I write it over here, y equals to negative 3x plus 7. The question says A is the point negative 1 and negative 5 and B is the point 3 and 3. Find the equation of the line perpendicular to AB which passes through the midpoint of AB. The first thing that you need to do is find the slope of AB. And the slope of AB is found by doing y2 minus y1 over x2 minus x1. That means you do 3 minus negative 5 over 3 minus negative 1. That gives us 8 over 4, that gives us 2. This is the slope of AB. Now let's say that we call the slope of AB M1. And the slope of the perpendicular line, let's call that M2. We don't know that. In order to find the slope of the perpendicular line, if I multiply the slope of these two lines together, I should get negative 1. That means I put 2 over here and I do M2 is equal to negative 1. So M2 is going to be equal to negative 1 over 2. This is the slope of the perpendicular bisector of AB. Now, midpoint of AB, that means we need to find the midpoint of AB because the line that is perpendicular to AB passes through the midpoint. So the midpoint formula is you add the x values, that means you add negative 1 and 3 and you divide it by 2. And you add the y values that means you add negative 5 and 3 and you divide it by 2. When you do this, this becomes 2 over 2. Negative 5 plus 3 is negative 2 over 2. The midpoint becomes 1 comma negative 1. So now you have the midpoint and you have the slope of the perpendicular line. That means you have y equals to negative half x plus c. We still need c, that is the value of the y-intercept of the perpendicular line. So you plug in this value of the midpoint, these coordinates in place of x and y. I plug in negative 1 in place of y and I plug in 1 in place of x. So this gives me negative 1 plus 1 over 2 is equal to c. So c is going to be, I think, negative 1 over 2. Let me see. Just checking. Negative 1 plus 1 over 2, just so that I don't make a mistake. Yes, that is correct. So the equation of the perpendicular bisector is going to be y equals to negative 1 over 2x minus 1 over 2. That's my answer. I write it over here. Y equals to negative 1 over 2x minus 1 over 2.